We are going to be looking at how to determine groups and periods of elements. Like I said earlier, we have two electronic configuration formats. We have the KLMN electronic configuration format, which is also known as the shell electronic configuration. This is the old electronic configuration style provided by two scientists, Neubel and Rutherford. Then we also have another style, which is the modern electronic configuration, known as the SPDF formation. Is that got to now? So, for instance now, if I want to write the electronic configuration of sodium, in KLMN format, it is going to be 2, 8, 1. Meaning that 2 electrons will be in the first shell, 8 electrons will be in the second shell, then 1 electron will be in the third shell. KLMN. So this is the first, the second, the third, the fourth. If you want to know the maximum number of electrons each of these shells can accommodate, you just make use of this formula, 2n squared, where n is the number ascribed to this. So for k, that will be 2 into 1 squared. That gives us what? 2. For n, that will be what? 2 into 2 squared. That gives us 8. Is that clear? For m, that will be 2 into 3 squared. And that gives us 3 squared is what? 9. 9 times 2, 18. Then for n, that will be 2 into 4 squared. Then that gives us 32. So the maximum number of electrons K can accommodate is 2. For n it is 8, for n it is 18, and for n it is what? It is 32. Are you getting it now? So if you want to write the configuration of sodium in KLMN format, it is 2, 8, 1. Are you getting it now? But in SPDF format, it is 1s2, 2s2, 2p6, 3x1. Is that got to now? Now, how do we use this to determine the group and period? Let me give it that. What we call group? On the period table, the vertical arrangement of elements is the group. Is that got to now? The horizontal arrangement of the elements is what we call the period. Are you getting it now? As I'm standing up now, I'm in a vertical position. A sleeping person is lying down horizontally. A standing person is lying down vertically. Is that got to now? Now, to use the knowledge of periodic table, electronic configuration to determine group and period, we do it like this. It is so simple. Look at oxygen. Oxygen has an atomic number of 8. Are you getting it now? So, if you want to use KLMN, let me just bring the two styles. The KLMN and the SPDF style. The KLMN electronic configuration will be what? Then the group and then the period. For the KLMN, that will give us 2, 6, because the rule we normally use for KLMN is octet rule. And octet rule dictates that 2 electrons will be in the first shell, then 8 electrons will be in the second shell. Is that got to now? For SPDF, oxygen we have 1s2, 2s2, 2p2. How do we use to determine the group and the group and period? 2p4, sorry. 1s2, 2s2, 2p4, because the total number of electrons is supposed to be 8. Is that got to now? Now, the valence shell electron here is 6. This represents the group, meaning that oxygen belongs to group 6. What do we mean by valence shell electron? Valence shell electron means outermost shell electron. You know, if you want to arrange this on shell, we are going to put 2 electrons in the first shell. We'll put 6 electrons in the second shell. Are you getting it now? So the outermost shell of an atom is also called its valence shell. I hope that is got to now. Now, the number of electrons in the valence shell represents the group. Is that clear now? Then the number of electronic shell. How many electronic shells do we have here? This is 1. This is 2. That one represents the period. Is that clear now? To count the number of electronic shells, this is shell 1. This is shell 2. I hope that is clear. Now, if we want to use SPDF to determine group and period, can we actually use that? Yes. We have 1s orbital. We have 2s and 2p orbital. Among these orbitals, which one do you think is the largest? 2. 2 is the highest orbital. There is no orbital that is greater than 2. Is that got to now? But we have 2s and 2p. What's the total number of electrons on the highest orbital? That is 4 plus 2. That gives us what? 6. That represents the group. And what is the number ascribed to that highest orbital? 2. That represents the period. So that is how you can use SPDF to determine group and period. Let me bring 2 or 3 more examples to make it clearer. Let's try sodium now. Sodium. You know sodium has an atomic number of 11. That will be 2, 8, 1. The K shell will take 2 electrons. The L shell will take 8 electrons. Then the remaining 1 electron will be transferred to the next shell. Are you getting it now? For SPDF format, we have 1s2, 2s2, 2p6, 3s1. That's the SPDF electronic configuration. Now, how do we get the group? You know, I told you for K element, the electron will be arranged like this: 2 electrons in the first shell. The second shell, 8 electrons. The third cell, 1 electron. How many electrons do we have in the valence shell? Just 1 electron. And this is the electron that represents the group. Meaning that sodium belongs to group 1. How do we get the period of sodium? How many electron shells do we have in total? 1, 2, 3. We can count it here too. This is the first shell. This is the second shell. This is the third shell. Is that good to now? So, meaning that sodium is in group 1, period 3. Is that clear? Can we use SPDF to determine that? We have 1s orbital. It's not the highest. 2s is still greater than 1s. We have 3. 3 is the highest orbital here. There is no orbital that is greater than 3s. Are you getting it now? So, how many electrons do we have in the highest orbital? 1. That denotes the group. And what is the number of the highest orbital itself? 3. That denotes the period. I hope that is gotten. Now, let's try the last example now. Calcium. Calcium has an atomic number of 20, right? That will be 2, 8, 8, 2. The group will be what? The outermost shell electron, which is 2, right? Yes. Meaning that calcium is in group 2. The period is what? How many electronic shells do we have all together? 1, 2, 3, 4. Period 4. Can we try that using SPDF? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Is it up to 20? 2 plus 2, 4, plus 6, 10, 12, 18, 20. Good. What's the highest orbital here? 4. The highest orbital here is 4. There is no number greater than 4 in this configuration. Now, how many electrons can we find in that highest orbital? Just 2. That represent the group. Then what is the highest orbital itself? That represents the period. Period 4. Is that got to now? So this is the simple method of determining the group and period of element using the shell and the SPDF electronic configuration.